Hello and welcome back. We were doing 15th group, so we'll continue with that. This video is going to be quite a smaller one. In this video, we'll be finishing up with the 15th group. Well, in the last class, I told you that brown ring test is something which is important for nitrate ion detection. I had a perception that you people can do that in your practicals, but now I think that I should explain it to you. Well, as far the ring of nitrate ion for the detection of nitrate ion is concerned, that is formed only when there is availability of Fe2 positive ions. Because these Fe2 positive ions, they reduce nitrate ion to nitric oxide. So we'll see how it happens. I'm telling you, the brown ring test. Now suppose you got nitrate ion, which is NO3 single negative, and you got Fe2 positive ion also. They'll react in acidic medium, that is H positive ion, to form NO, nitric oxide, plus 3 moles of Fe3 positive plus 2H2O. I said that Fe2 positive, they oxidize. They reduce nitrate ion to nitric oxide. So in this process, iron itself undergoes oxidation. Now here nitric oxide which is formed will react with complex, that is Fe H2O whole 6 2 positive plus NO will form Fe H2O whole 5 NO 2 positive plus H2O, and the brown ring which you see is of this complex, so it forms brown ring. We're left with two compounds now, that is PH3 and halides of phosphorus. So first we'll see phosphine, PH3, that is phosphine. How to form phosphine? The reaction which I am going to tell you is quite an important one. You react P4 with 3 moles of NaOH plus water. On heating in an inert atmosphere of CO2 will give you PH3 plus 3 moles of NaH2 PO2. So here you have got phosphine. This reaction is very important, and this is an in-text question of your textbook, where it is asked that what happens when white phosphorus is heated with sodium hydroxide in an inert atmosphere of CO2. You'll get phosphine. Phosphine can also be prepared by the reaction of phosphonium iodide with a base like potassium hydroxide. It will give you potassium iodide plus H2O plus PH3. So this is what you can get. Phosphine can also be obtained by the reaction of compounds like calcium phosphide with water. So on reaction with water, it is going to give you compound like calcium hydroxide and PH3, 2 moles of PH3. Likewise, you can react the same compound, that is Ca3P2, with an acid also like HCl. In that case, you will get 3 moles of CaCl2. This is the only difference, along with 2 moles of PH3, which you will get. This is the method of preparation of phosphine. As far the properties of phosphine are concerned, I have already taught you. They are very similar to NH3. We have done hydrides of 15th group, in which we have done NH3, PH3, SPH3, ASH3, BIH3. We have talked about their basic characters. So its properties are very similar to that of ammonia. The only thing is, like ammonia, it can react with a large number of metals. It can act as a ligand also, where it will donate its lone pair of electrons. So we can see some of the properties of phosphine. Suppose you have got a compound like copper sulfate, CuSO4, and you are reacting it with pH3. So 3 moles of CuSO4 will react with 2 moles of pH3 to give you Cu3P2 plus 3H2SO4. Same type of reaction can occur if you react pH3 with mercuric iodide. So I am writing that is HgCl2 plus pH3, that will give me Hg3P2 plus 6 moles of HCl. So let me balance it. It is 3, here you'll have 2. So it can convert metal salts into their corresponding phosphides. This is all about the properties of phosphine. Next we'll see halides. Phosphorus exists in two types of halides, that is Pcl3 and Pcl5 type. That is Px3 and Px5. Common one are Pcl3 and Pcl5. First we'll see Pcl3. Pcl3. Well, now we can prepare it. If you react phosphorus with chlorine, limited supply of chlorine, you'll get compound PCl3. So here P4, 6 moles of Cl2 will give you 4 moles of PCl3. Likewise, you can carry out chlorination of P4 with SOCl2 also. SOCl2 you have used in organic chemistry. You will get PCl3 along with SO2 and S2Cl2. So let me balance it. So this is how the reaction will proceed. This is how you can prepare PCl3. Properties of PCl3 as far they are concerned, you have already done them in organic chemistry, in preparation of alkyl halide from alcohols. So they are the common properties of PCl3. PCl3 structure also, very commonly you know that it is very similar to that of ammonia, NH3, pyramidal structure, where you have got a lone pair of electron and you have 3 Cls attached to it. Now last we will talk about PCl5. PCl5. If we talk about preparation of PCl5, PCl5 can be prepared again by reaction of P4 with chlorine, but excess of chlorine. So here in this case it will react with 10 moles of chlorine to give you 4 moles of PCl5. Likewise, P4 can also be reacted with thionyl chloride, that is 10 moles of SO2Cl2. It is not thionyl. In fact, I have written sulfuryl chloride. Thionyl chloride is SOCl2. So 10 moles of this, that will give you 4 moles of PCl5 along with 10 moles of SO2. So this is how you can prepare it. And the properties again you know very well. You have done them in organic chemistry in the preparation of halogen derivative from alcohols on reaction by reaction with PCl5. Here I would like to tell you the structure of PCl5. Well, as far as the structure is concerned, you have already done that in your 11th standard. It is trigonal bipyramidal, Cl, 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 Cl. So this is trigonal. Here you have trigonal symmetry and you have pyramidal symmetry also. So one pyramid on the bottom side, one on the top. You know that axial bonds are very long as compared to equatorial bond. That's why Pcl5 has a prominent tendency of dissociating into Pcl3 plus Cl2. One more thing, Pcl5 can act as an oxidizing as well as reducing agent. It has a tendency of donating electron in the form of chloride ion. If a question is asked to you, please do remember and please do pay attention toward this question. Whether Pcl5 will act as an oxidizing or reducing agent, your answer will be it can act both as an oxidizing as well as reducing agent, but phosphorus in Pcl5 can act only as an oxidizing agent. Because in Pcl5, the oxidation state of phosphorus is +5. It can only gain electron. It cannot lose electron. So it will act only as an oxidizing agent. But as for Pcl5, as a compound is concerned, it can lose as well as gain electron. I tell you how. Suppose I have 2 moles of Pcl5. In their solid state, Pcl5 exists in ionic form. One of the Pcl5 will lose electron in the form of Cl negative, which another one will gain. The one which will lose electron will become Pcl4 positive, and the one which will gain will become Pcl6 negative. So in the solid state, Pcl5 exists in ionic form, where it can means we can say that it can easily gain or lose electrons in the form of chloride ion. So you have Pcl4 positive and Pcl6 negative. So this is all about 15th group. We have done all the compounds of 15th group and hope everything is quite clear to you. In case you have any doubt anywhere, you got my number. You can call me anytime or send me a message. I'll definitely revert back to you. Please do practice them a lot. And please do subscribe my channel in case you have not done that. Thank you very much.